Volume's been turned off for how long? Anybody notice? All right, hopefully not too long. So that first whole video might be silent. That would suck. And this one is only starting now. All right, so one of the things that's really important is being able to write things as a single logarithm. So when you look at your log laws, we call the right-hand side here of our log laws as the expanded form, and the left-hand side as a single logarithm. So a single logarithm doesn't have any numbers in front and has things multiplied and divided inside of that logarithm. So as far as putting things together, the first thing you're going to look for is that power rule. Anytime you have a number in front, it can go in as an exponent. Even though I see an adding here, the first thing I'm going to do is put that 3 in as an exponent, because my adding log law only works if it's a log plus a log with no numbers in front. So with that 3 in front, I can't use my adding log law, but that 3 in front can be put in as an exponent, because that's our power rule for log laws. Now I'm adding a log plus a log. That's the same as multiplying. And now we've written it as a single logarithm. Part B, again, I notice that there are some numbers in front. So when I'm putting them together as a single log, the first thing I'm always going to do, those numbers in front can go in as exponents. I'm going to do this one in 2 steps, and then I'm going to show you a shortcut at the end of what you can do if you have more than one log, adding and subtracting. So here, a log plus a log, adding them means we can multiply. And then subtracting them means we can divide. Now I'm going to want you to go directly from here to here. And I'm going to show you one more example, which I hope helps you see what you're going to need to do. So we're going to call this example B.5. It's in between B and C. Okay? And I'm going to write this one as a single log. I'm going to have log A. I'm going to pretend I took all the time to put those numbers in front beforehand. So log A minus log B squared plus log C cubed minus log D plus log E. I ran out of room, so that's as many as I could do. We could do a lot more. I want you to see how and what my shortcut is when I'm adding and subtracting a bunch of logs, that I can go directly to this. How did I go from there to there quickly? How did I know what was going to be on the top of my fraction? How did I know what was going to be on the bottom of my fraction? Whatever is a positive one, that goes in the top, because that's your multiplying and multiplying things together. Whenever you're subtracting, that's your dividing. So whatever is being subtracted, the b squared and the d, that will be divided. And you're going to find that any time you're adding or subtracting more logs, this will be the easiest way of going about it. If you try to do them one at a time, chances are you might forget brackets or make a mistake along the way, so this will be the best way to do it. And finally, part C, we want to write this as a single logarithm. We have log 2 of 6 minus 3. Well, the only way we can put things together as a single logarithm is if we're adding or subtracting logs with the same base. Right now, I have log base 2 of 6, subtract a number. So the question I have is, could you write log 3 as log 2 of something? What would have to go right there to make it equal to 3? Again, this is where we really have to know what a log means to do this mental math. Log 2 of what equals 3? 8. Because what does log 2 of 8 mean? 2 to what power is 8? 3. So since 2 to the 3 equals 8, log 2 of 8 equals 3. And now you could put this together as a single log. We're subtracting, so that's dividing inside your logarithm. And you could reduce that to 3/4 if you would like. Five, 8, 11, and 18.